Hi, I'm Sean.
And I'm Dale.
And what are we going to talk about, Dale?
I think you're going to animate a UI view.
Exactly. So we're going to talk about animations, and let's look at the storyboard for what we're going to do. We have a view and 4 buttons. So the view is centered, and it has a width and height constraint. Those centers are actually very important, and pay attention to them. I named them View Center Y and View Center X over in the constraints in the document outline just for our sake to actually visualize it as a concept. Then down here we have 4 buttons touching each other. Up, down, right, left. I bet you can tell what they're going to do.
Up, down, right, and left. Yep.
So let's build and run this right now. And let's see what it actually does. So notice how when I press right, it animates right. When I press down, animates down, up, left, left. And now we're back into the center. But that's besides the point. So let's start looking at the code. And animations are actually fairly simple in Swift and in Objective-C. UIKit actually has a set of animation blocks that you can call on a UI view that is just very convenient and does, well, all of the work for you. So let's take a look at the very top and we'll go through it. I have 2 IB outlets to our center constraints. These are the same center constraints on our UI view that we named the exact same thing.
So constraints are actually objects.
Exactly.
And so we can have IB outlets to them like any other object, and you're going to be modifying the constraint on the fly.
Yes. So let's look at the storyboard real quick, and let's bring up the assistant editor. Notice when I hover over the circle that says what element, it highlights the one corresponding to it. Notice how it highlights the constraint instead of the actual UI view. So you can actually modify those constraints by accessing the dot constant property within it and changing that value accordingly. So
is the dot constant the equivalent of the delta that we've dealt with before?
Exactly.
Okay. So
then after those 2 IB outlets, we have 2 variables, time interval and distance delta. And by variables, I mean constants. But time interval will be the length of our animation, so how long it is in seconds. So while up here in seconds. And then our distance delta is going to be our delta that we add to our constraint for the delta fact.
And that's in points.
And I was actually playing around with something that's not needed. So we don't need to do any initial setup for our animations. In view did load, nothing occurs. Did receive memory warning, nothing occurs. And then we get to our first IB action for one of our first buttons, and this button is up. So when a user presses up, we want to animate. So there's multiple different kinds of block animations, some with very little parameters you pass in, and ones with a lot of parameters passed in to get the behavior that you personally want. So I'm going to comment out this large one real quick and show you uncomment out this little one and just talk through this real quick. So UI view is animated with duration. Animated with duration takes in a time interval as well as a closure. And we're just doing what type of closure is that, Dale?
Following?
Trailing.
Trailing
Closure. And the parameter we're passing in, though, is the time interval. So how long we should take to animate.
Can we hover on animate with duration? Does it do documentation?
It does documentation.
So the closure, if we were going to supply it, would be animations :
Exactly.
Okay.
And so within that closure block, it says a block object containing the changes to commit to the views. And that's all it is. We are making changes to a value, and then since it's in that closure, Apple behind the scenes is going to animate the view.
And so we don't, oftentimes when you animate, you have to tell it what to do for each step. You're basically saying, I want this thing to occur. I want the constant to change by this amount. But then rather than that amount happening all at once,
we're telling it to happen over 2-second periods.
Okay.
Then in here, we change our delta for our center Y to add our distance delta to it. And then we do self.view.layout if needed. And we actually discovered through Apple's documentations online that when modifying a constraints constant, you have to call that because it forces the layout of the subtree animation block and then captures all the frame changes.
Without that, it simply jumps the distance delta.
Yep, and that was an exact quote from Apple.
And we should also point out, because you're inside of a closure, self is needed.
Self for variables and constants outside of that closure, self is needed to actually access those values. So that's just a simple animation block. That's saying, hey, we're going to add 50 to that over a 2-second period. And if I build and run this now, and we click up, it adds 40 to it over a 2-second period.
So while we're there, let's comment out the layout if needed and run it again and show what happens if that's not there.
So Dale actually discovered this behavior when we were playing around with it, and he said, what?
That doesn't look like it's animating over 2 seconds to me.
Exactly. So we went into Googling mode and we uncovered a nice little article of Apple posted a few years back saying you needed that layout if needed, so the animation tree is passed along essentially. So we're going to uncomment that out because that's needed, but we're now going to comment out this little animation block.
So in this one, that animation is actually happening in a very linear fashion.
Exactly.
And now you're about to show us something that varies the animation rate and kind of dynamics of it, right?
Yep. This is one of the longer animate with duration methods that you can call, and it takes in a lot of parameters. It takes in the duration just like the previous one, which is the total duration of the animations measured in seconds, just like we talked about earlier. It takes a delay, which is also an NS time interval, and it does just that. It delays the start of the animation. So, for example, if we passed in 10 seconds, it would wait 10 seconds and then do its 2-second animation. Then dampening ratio. So what this is, the dampening ratio for the spring animation as it approaches its quiescent state. What that is it's going to act like a spring. It's going to dampen and oscillate just like a spring would when getting close to the start and end.
And that's quiescent state. So basically, what is happening here is when you have a spring, it k equals fx as
Yes.
the x changes, or f equals kx is what I meant to say. The force is changing. It changes. It's like a deceleration, I suppose. Mm-hmm. Okay.
Then the next one is initial spring velocity. So if that spring had an initial velocity, what are we going to set that to? That takes in, I believe, a CG float. Yep. And then it has options. So we could pass in a multitude of different options for this animation to take place. But I did a UI view animation options.curve ease in and out. And if we click that, it's an ease in, ease out curve causing the animation to begin slowly, accelerate in the middle, and then slow again before completing. And what that is, it's just going to be a nice little curve. So it's going to slowly start, get really fast, and then slowly end. And then we do our animation block just like before, where we do our changing our constant, we're then calling layout if needed, and then they have a completion handler as well. What that's going to do is that completion handler is going to be called the second millisecond right after the animation is completed.
So maybe we would have multiple animations in a row. We could say, do this one. When that's finished, go on to the next one. Or the animation completes and then you fire off some other activity.
Like cleaning up or something. So let's see what this animation, animate with duration, actually appears like in the storyboard. So if I click up now, notice how it kind of accelerated and then slowed down again. And notice how it kind of oscillates when we get close to the top. You can't really tell, but maybe let's make the scale a little bit bigger. Maybe we'll be able to see it then. So pressing up again. Oh, notice how it bounces a little bit? That's because of the spring dampening.
So let's change the initial velocity and see what effect that has.
To 10?
Yeah, don't know what these numbers mean at this point, so anything will work for me. Woo!
And, well...
It actually backed up.
Yeah, it bounced. It had such a high velocity that it hit the wall and bounced back a little bit.
Cool. How about let's add a little delay to it.
We could add a delay by simply changing this value
2
to
seconds.
2. So we have a 2-second delay, and then we have a 2-second animation, so that's 4 seconds overall. Apple recommends that your animation happens between 0.5 seconds and 0.7 seconds. Mind you, that's if you're using UI elements to animate those onto the screen, such as a UI text field or something, or a segue.
They don't want us to get bored.
They don't want the user to get bored. So if I click up now and we watch the delay.
1,000, 2, 1,000.
There we go.
Yep. Cool. So let's try and implement a completion handler that maybe changes a label and says finished.
Finished.
So we can do the completion handler as an inline closure?
Okay.
Can we do that?
Yep.
We're already inside of a closure, right?
Yep.
So we need a label in the UI so that we can say something.
Oh, did not want that. So it's saying that I don't have the correct parameters because of the fact that it takes a bool and returns a void. So I could say, how do I do this, Dale? Walk me through the syntax.
Ooh.
Okay, so if you're ever confused about this, there is a way you can figure it out.
Okay.
So if I'm typing the method again, so animate with duration over using spring dampening. Notice, by the way, all the other methods that you could animate with. You can simply double click one of these blue boxes.
And it'll turn it into code?
And it will turn it into the closure, and it'll even highlight what you want to call bool.
So it's parameter, arrow, return type, in, and then our block of code.
Because I'm super lazy, I'm actually just going to copy that.
Okay.
And then we could just paste that up here. And then there we go. We have our block of code that returns void. But we could do print line.
Okay. Yeah, we don't have to put it in the UI. That's fine.
And build and run this now. Remember, this still has the 2-second delay, 2-second animation. We could click up.
Boom.
And there our completion handler got called.
Yeah, I'm going to move him over so we can see that. So let's do that again. 1,000, 2, 1,000, go. Boom. Finished.
And notice how it was kind of slow at the very end. That's the spring dampening. It's slowly getting dampened out to a 0.
So let's turn the spring dampening down to, say, 0.5. Let's have no delay because that bores me. And the initial velocity, set that to 5. And here we go. Cool.
And notice how the spring dampening, it took a little time to slow down because with less spring dampening, that's what it does.